Hey guys, today we're going to look at really solidifying the concept of the derivative and making sure that we understand everything that we've covered so far. So we're going to look at pretty much what we've already done and maybe add on a couple of extra little things. So first of all, here we have the graph of f of x. Now this first question states, on what interval will f prime of x be greater than 0? If we're trying to figure out when the derivative is greater than 0, that means that the function would be increasing. So we would look at from what x to what x my function here is going up. So what I like to do is label or pretty much draw on my graph where it's decreasing and where it's increasing and writing down those x values. So on this end, we know that this is negative infinity, and on this end, it's positive infinity. It's going down first, and then it stops here, which this is approximately x equals negative, looks like to be about 1 point, let's say 3. Then it's going to go up, and it's going up until this point, which is at x equals 1.5. Then it starts going down until about this point, which this is x equals, and let's estimate here, we'll say 4.3. And then it's going up the rest of the time. So if I want to figure out when will my derivative be greater than 0, that's all of the arrows that are pointing up because that's where my function is increasing. So we would say from negative 1.3 to 1.5 union 4.3 to infinity. And our reasoning would be because f of x is increasing. Next, on what interval will f prime of x be less than 0? This is when my function is decreasing. And it is decreasing starting on this end, which is negative infinity, until negative 1.3, union 1.5, until 4.3. And our reasoning would be because f of x is decreasing. The next part says, use the graph of f of x to estimate the value of f prime of 3. And I put here to remember that the derivative represents the slope of the tangent line at that point. Now, I don't know what my derivative is or what my function is, so I can take the derivative, which is why it says to estimate. We can estimate this value by finding the slope of the secant line that runs almost, if not parallel, to the tangent line. So the secant line, remember, is a point on the graph that crosses your function. It's a line on the graph that crosses your function at 2 points. If I want to estimate the derivative at x is equal to 3, I would pick 2 points on either side because I'm going to end up using my slope formula. Remember that slope is y2 minus y1 over x2 minus x1. So I'm going to pick a point on either side. I have here x is equal to 2, so that is my coordinate 2, 4. Then on the other side, I have here at 4, and the y value is negative 4. So basically, if you're trying to estimate a derivative, you pick 2 points on either side, and then use those 2 coordinates to find the slope, since my secant line would go through those exact 2 points that would run parallel to my tangent line. So we're going to do y2 minus y1. Doesn't matter which one you say is your first point and which is your second. I'm going to say this is y2 and y1, and then x2 and x1. So I'm just going to label it. You could also have done this as x1, y1, x2, y2. That really does not matter. So y2 will be 4 minus negative 4, which becomes plus 4, over 2 minus 4. 4 plus 4 is 8, divided by negative 2, which gives me negative 4. So this is my estimate for f prime of 3. For this last question here, it says to write the equation of the tangent line at x is equal to 3. I have my slope now, because that's what I just found. The next thing that I need is my point of tangency. So at x is equal to 3, I can use my function to locate that y value, which is 0. So my coordinate there, my point of tangency, is at 3, 0. So my equation is going to be y minus 0 is equal to negative 4 x minus 3. And this would be the equation of my tangent line. Now we're going to look at a chart, which we haven't really seen charts before. So let's see how to use this chart to get all of the same information that we can get either from a graph or from an equation. On this chart, we have different values of x and different values for f of x. So for all of these, we're going to estimate the value of the derivative given these x values and using this chart. If I want to find the derivative of f prime of 0, or rather find f prime of 0, here's the 0. I can't find my derivative using the equation because I don't have an equation. So instead, I can use the slope of my secant line by choosing 2 points on either side. So remember, these are my x values, these are my y values. So you can do y2 minus y1 over x2 minus x1. So let's try that. Remember, these are my y's, these are my x's. So 2 minus negative 3 becomes plus 3 over x2, which is negative 3, minus x1, which is 1. And what we end up with is 5 over negative 4. So negative 5 over 4 is my estimate for the derivative. Now we're going to see, is the function increasing or decreasing? Since f prime of 0 is approximately negative 5 over 4, since it's negative, that means that my function will be decreasing. To find the equation of my tangent line, we need the point of tangency because I already have the slope. My point of tangency is given here in my chart. That point is 0, 1. So my equation would be y minus 1 is equal to negative 5 over 4 x minus 0. Let's try this next one. We want to estimate the derivative when x is equal to 1. So now instead, this is the point I'm focused on. And so I'm going to use the 2 points on either side. So I'm going to do y2 minus y1, so 1 minus 0, over x2 minus x1, 0 minus 4. 1 minus 0 is 1, and 0 minus 4 is negative 4, giving me my estimate of f prime of 1 to be negative 1 over 4. Since my derivative is negative, again, this means that my function is decreasing. And to find the equation of this tangent line, I have the slope. I need the point of tangency, which would be 1, negative 3. Remember, we're doing the exact same thing we've done before. Since we're given the x, we can just look on the chart here to get that point. So now we put this into the equation. Y minus negative 3 becomes plus 3 is equal to my slope, negative 1 over 4, x minus 1. Last one, we want to estimate the derivative at x is equal to 6. So now we're focused on this point, meaning we're going to use the points on either side to find that slope. So y2 minus y1, 4 minus 10, over 0 minus 2. 4 minus 10 is negative 6, and 0 minus 2 is negative 2. So my estimate for f prime of 6 is going to be negative 6 divided by negative 2, which is 3. Since my derivative is positive, that means that my function is increasing. I'm going to use the point here. This is my point of tangency. So 6, negative 7. And now I can write the equation. Y minus negative 7 becomes y plus 7 is equal to 3x minus 6. So essentially, we can do the same thing with charts as we do with graphs and equations. Let's continue with charts a little bit. This time, our chart here has the values of x and a derivative h prime of x. It tells us here in the description that the zeros indicated in the table are the only zeros of the graph of h prime of x. And we're going to use the table to answer those questions. The first question is, what are the critical numbers of the derivative? Remember that my critical numbers is when my derivative, in this case it's h prime of x, equals to 0. So I look at my chart here, and h prime of x is equal to 0 at these points. So these are my critical numbers, those x values, which is negative 2 and 7. For the next couple questions, we're going to figure out on what intervals it is increasing and decreasing, and then its extrema. Now keep in mind that when we were doing increasing and decreasing behavior and then finding extrema, we use number lines. And if you'd like, you can translate this chart as a number line. We have our critical numbers, which is negative 2 and 7. On the left side of negative 2, if we look at those derivative values, these are all positive. If we look between the critical numbers, the derivative values are all negative. And to the right of my critical number here, we see that those derivative values are negative. So this number line here represents my derivative. And I can use the number line instead of the chart to answer these questions, whatever you feel most comfortable with. For increasing, the function is increasing only on this interval here, which is from negative infinity to negative 2. And we would say because h prime of x is greater than 0. For decreasing, that's when my derivative is negative, which we have 2 intervals. Remembering that we have to stop at the critical number, because here my derivative is not negative, it is 0, which is neither positive nor negative. So my function will be decreasing from negative 2 to 7, union 7 to infinity. And we would state because h prime of x is less than 0. For the next one, at what values of x does the graph of h of x have a relative maximum? Now we have a maximum when the derivative changes from positive to negative. So that means that we have a maximum right here at x is equal to negative 2. And the reasoning would be because h prime of x changes from positive to negative. At what values of x does the graph of h of x have a relative minimum? If we look at our number line, we only have a minimum when the derivative changes from negative to positive. But over here, it goes negative to negative. Therefore, h of x that has no minimum. And we would say because we always want to justify our answers, h prime of x does not change from negative to positive. If h of 3 equals 2, what is the equation of the tangent line to the graph of h of x at x is equal to 3? So what they've given here and what I've underlined, this is my point of tangency. The other thing that we need is my slope, so I need h prime of 3. And luckily here this chart represents my derivative values. So since I'm looking for h prime of 3, I look at my x value, this is 3, my h prime is negative 3. So now I have my point of tangency and my slope, so my equation would read y minus 2 is equal to negative 3, x minus 3. The next part is what is the equation of the normal line to the graph of h of x at x is equal to 3. Remember that the normal line has a perpendicular slope to the tangent line. Since the slope of my tangent line is negative 3, that means that my perpendicular slope is positive 1/3, since perpendicular slopes are always the opposite reciprocal. Now to write the equation, it still goes through the same point of tangency. So when I write my equation, it would be y minus 2 is equal to 1/3 x minus 3. Now let's revisit the normal line, just to really understand how or what a normal line is. Picture to the right here is the graph of f of x. So let's go through these motions here. The first thing we're going to do is estimate the value of f prime of 1. So here's 1. I'm going to choose a point to the left and to the right of 1. So I can choose, you can choose any points you would like. Let's say if you choose 0 and 2. So these coordinates are 0, and then this point here is right in between 3 and 4, so we would use 3.5. And this one would be 2, negative 0.5. To estimate, we're going to find the slope. So y2 minus y1, 3.5 minus negative 0.5 becomes plus 0.5 over 0 minus 2. And we get 4 over negative 2, which is negative 2. So my estimate here, f prime of 1, is approximately negative 2. Now, whenever you estimate, you can always check your value of the derivative and make sure that it matches the behavior of your graph. Since my derivative is negative, that means that my function should be decreasing, and it is, so it makes sense. Next, we're going to find the equation of the tangent line to the graph of f of x at x is equal to 1. I have my slope, now I need my point of tangency, and that point is 1, 2. So I can use my point, f of 1 is equal to 2, and my derivative, f prime of 1 is equal to negative 2, to write my equation, which would be y minus 2 is equal to negative 2 x minus 1. Once again, the normal line is the line that runs perpendicular to the tangent line at that point of tangency. So just so you can have a visual, if this is my tangent line, then my normal line runs perpendicular. And it still goes through the same point of tangency, but now the slope is going to be the opposite reciprocal, because perpendicular slopes are just that. Since the slope of my tangent line is negative 2, that means that my perpendicular slope is 1/2. And I'm still going to use the same point of tangency, which is f of 1 is equal to 2. Your equations essentially for a tangent line and a normal line look almost identical, except the slope is what changes. So my equation would be y minus 2 equals 1/2 x minus 1. Okay, now here we have the graph of the derivative. So we're always going to be going back and forth so you can get a handle of how to read these graphs. For all of these, we're going to identify the characteristics about the graph h of x, and then we're going to justify. So remember, this is the derivative. The interval where h of x is increasing, that's what I want to get first. So when you have the graph of your derivative, your x-axis pretty much separates your positive and negative derivatives. So everything up here is positive, everything down here is negative. And these values where it touches your x-axis, these are my critical numbers because that's where my derivative is equal to 0. So my interval where h of x is increasing would be from -2 to 1, because that's where it's all positive, and again from 3 to infinity. And we would say because h prime of x is greater than 0. Now the interval where h of x is decreasing, that's any time it's below the x-axis. That would be from -infinity, because that's the left edge of my graph, to -2, union from 1 to 3. And we would say because h prime of x is less than 0. Now the values of x where h of x has a relative maximum is from when my derivative changes from positive to negative. So here at this point it goes negative to positive. Then here it goes positive to negative, and then here it goes negative to positive. So we have a maximum right here at x is equal to 1. And we would say because h prime of x changes from positive to negative. Now for the values where h of x has a relative minimum, that's where my graph changes from negative to positive. And so we have two. We have here and here, because again, it goes negative then positive, and then again here, negative and positive. So we have minimums at x is equal to -2 and x is equal to 3, because h prime of x changes from negative to positive. Now here we're told if h of -1 is equal to 1/2, what is the equation of the tangent line drawn to the graph of h of x at x is equal to -1? So what I'm given here, this is my point of tangency. What I need is my slope, which is the derivative, h prime of -1. Since this is the graph of h prime, that means that h prime of -1 is 2. I just look at my y value when x is -1. So my equation would be y minus 1/2, because that's for my point of tangency, equals 2 times x minus -1, so plus 1. If h of 2 is equal to -3, what is the equation of the normal line to the graph of h of x at x is equal to 2? So we have here our point of tangency, which is the same point that the normal line goes through. So what I need is the slope of the normal line. To find the slope of the normal line, we first need to find the slope of the tangent line. And then I would do the opposite reciprocal to get that slope of the normal line. H prime of 2, here's 2, is -1. That means that my perpendicular slope would be the opposite reciprocal. So the opposite would be positive, and the reciprocal of 1 is still 1. So my equation would read y minus -3, so plus 3, is equal to 1 times x minus the x value, which is 2. Let's continue with another graph. Now in this case, our graph here is g of x, so not the derivative, but the actual function. Based on the graph, at what values does the graph have a horizontal tangent? give a reason, and show an algebraic analysis that supports your answer. So we're going to use the graph to find out when we have a horizontal tangent, and then we're going to confirm that by finding it algebraically, meaning through finding the derivative. So when I look here at my graph, and we have a horizontal tangent whenever my function has extrema. As you can see here, this is a maximum. That means that I would have a horizontal tangent line at that point, which is at x is equal to 1. So we would say because g of x has extrema. Now to confirm using algebra. We have that g of x is equal to 2 square root x minus x plus 2. I would need to find the derivative, but I can't find the derivative using this equation. So let's rewrite it so I can find the derivative. This would be 2x to the positive 1/2 minus x plus 2. Now that I've rewritten that radical with the rational exponent, I can take the derivative. So g prime of x is going to equal to 1/2 times 2, which is 1, so x, and then subtract 1, meaning I'm going to subtract 2 over 2, would give me negative 1/2 minus 1. To find out when it has a horizontal tangent, that means that my derivative is equal to 0. And now we're going to use this to solve for x. So first, we would rewrite this so that it's back to the radical so I can easily figure out what to do with it. This is 1 over x to the positive 1/2, since that negative exponent means it goes down to the numerator. And an exponent of 1/2 means that it's the square root. Minus 1 equals 0. So first I'm going to add the 1 over. So I get 1 over the square root of x is equal to 1. Now I can't solve for x while x is in the denominator, so I'm going to multiply the square root of x to both sides. So that way I can cancel it out here, and now it's no longer in a denominator. So I have 1 is equal to 1 square root x, which is just square root x. And to solve for x, I would square both sides. And so the square root cancels with the exponent, so x is equal to 1 squared, which is 1, which is what I got over here by using the graph. Next, it says on what intervals is g prime of x greater than 0? And then on what interval is g prime of x less than 0, and give a reason for your answers. So first let's start with g prime of x is greater than 0. This would mean that my function is increasing if my derivative is positive. My function is increasing starting at 0 to 1. And we would say because g of x is increasing. Next, let's figure out when g prime of x will be less than 0. And this is when my function is decreasing. And is decreasing the rest of the time, so that would be from 1 to infinity because g of x is decreasing. Finally here, for what values of x is the slope of the tangent line equal to 2? Remember that slope of the tangent line, that is the derivative, so g prime of x. And we want to know when g prime of x is equal to 2. I already have my equation for g prime of x, which is over here. So I'm going to make that equation 1 over square root of x minus 1 and make it equal to 2. And now we solve. So first I would add the 1, just like we did here, those same exact steps. So 1 over the square root of x is equal to 3. Next, we can multiply the square root to both sides, so we can remove it from the denominator. So we have 1 is equal to 3 square root x. Now I can divide the 3. So I get the square root of x is equal to 1/3. And then I can square both sides. Keeping in mind that when you square a fraction, you square both the numerator and the denominator. So my answer here would be 1 over 9. Okay, here we have this function. And this is, we're going to review how to get intervals of increasing, decreasing, and your extrema given the equation. So we're moving away from the graphs for this one. We have that f of x is 2 over 3 x to the third minus 3x squared minus 20x. In order to find intervals of increasing and decreasing and extrema, we first need the derivative. The derivative here, I would apply the power rule. 3 times 2/3 would be 2x squared minus 6x minus 20. And we're going to make it equal to 0. Now I need my critical numbers. We're going to need to factor this. If we see all of these numbers, everything is divisible by 2. So I can factor out a 2. Now I can factor that quadratic. So we get 2 x squared minus 3x minus 10 can be factored to be x minus 5, x plus 3, giving me my critical numbers of x equals positive 5 and negative 3, since that's what would make these factors equal to 0. Now I'm going to create my number line. So we can check to see when my derivative is positive and negative. Making sure to keep your numbers in order. So I'm going to put negative 3 and 5. Now I'm going to take numbers in between each interval and plug it into the derivative to take note of the sign. To the left of negative 3, I'm going to choose to plug in negative 4. When I do that, 2 here is always going to be positive. So negative 4 minus 5 is a negative, and negative 4 plus 3 is negative. So positive, negative, negative gives me a positive. Between negative 3 and 5, I'm going to plug in 0. If I plug in 0, we get this 2 here, which is positive. 0 minus 5 is negative, and 0 plus 3 is positive. So a positive, negative, positive gives me negative. And finally, now I'm going to plug in 6. So again, that 2 is positive, 6 minus 5 is positive, and 6 plus 3 is positive, giving me all positive. So now for my increasing behavior. That's always where it is positive. So this would be from negative infinity to negative 3, union 5 to infinity. And we would state because f prime of x is greater than 0. Now for decreasing behavior, that's where my derivative is negative. So from negative 3 to 5. And the reason would be because f prime of x is less than 0. At what values of x does the graph of f of x reach a relative minimum and maximum? We have a minimum at x is equal to 5. And this is because my derivative, f prime of x, changes from negative to positive. Now for the maximum, we have a maximum at x is equal to negative 3, and the reason is because f prime of x changes from positive to negative. Finally, here we want to know what is the equation of the tangent line at x is equal to 4. So I'm going to need to do two things. I need f of 4, which is my point of tangency. So let's plug that in. So we get 2 over 3, 4 to the third, minus 3 times 4 squared, minus 20 times 4. 4 to the third is 4 times 4, so 16 times 4 is 64. And then we're going to multiply 64 with 2 over 3. So 2 over 3, I'll do that over here, times 64 over 1. 2 times 64 is 128 over 3. So 128 over 3 minus 4 squared is 16, and 16 times 3 is 48, minus 80. Now, in order to get this number, we need to put everything over the common denominator, which in this case is 3. So if I put this over 3, I'm going to have to multiply the numerator by 3. And this over 3, multiply the numerator by 3. So what we get here is 128 over 3 minus 48 times 3 is, let's do that over here. This is 144. So minus 144 over 3 minus 80 times 3 is 240 over 3. So now we need to subtract all of this. We got to do the 128 minus 144. So let's see, we have 144 minus 128. This will be 14, this would be 3. So we would get here 14 minus 8 is 6, so 16. So that's going to be, this here is negative 16 over 3 minus 240 over 3, which is going to equal to negative 256 over 3. So that is my point of tangency, which I'll write here. F of 4 is equal to negative 256 over 3. Now we also need, remember we needed two things, the point of tangency, and now we need the slope of tangency. So f prime of 4. So I'm going to go to my derivative, which is, you can use the normal version here, or you can use the factored version. I like to use a factored version because it makes my multiplication easier. So that would be 2 times 4 minus 5 times 4 plus 3, which is going to equal to 2 times negative 1 times 7, which gives me negative 14. So now that I have my slope and I have my point of tangency, I can write the equation of that tangent line, which would be y plus 256 over 3 is going to equal to negative 14 x minus 4. All right, last question for real. Pictured below is the graph of p prime of x. Use the graph to answer the following questions and justify your answer. So on what interval is p of x decreasing and where is it increasing? So again, since this is the graph of the derivative, that means that the x-axis here is going to separate the positive values and the negative values. Every time the function is above the x-axis, that means that the function would be increasing, and any time that the function is below the x-axis, that means that the function is decreasing. So we have our x-intercepts here. These are when my derivative is equal to 0, which when it's equal to 0, my function is going to be neither decreasing nor increasing. So let's start with decreasing. My function will be decreasing when the derivative is below the x-axis, so it's this entire time here. So it's going to be from negative 3 until 0, since that, remember, the derivative is equal to 0 though there, which is not negative, so we have to stop there. And then again from 0 to 3. And we would state because p prime of x is less than 0. Now, when my function is increasing. Increasing would be when the function is above the x-axis. So that's this section here, which is from negative infinity to negative 3. And then again over here, which is from 3 to infinity. And we would say because p prime of x is greater than 0. Now, at what values of x does the graph of p of x reach a relative maximum or a minimum? So a maximum. We have a maximum when the derivative changes from positive to negative, which we can see is right here. So that would be at x is equal to negative 3, because p prime of x changes from positive to negative. Now we have a minimum when the derivative changes from negative to positive, which means it crosses the x-axis from below to above, which occurs here. So there is a minimum at x is equal to 3 because p prime of x changes from negative to positive. And that's it. I hope you found this review helpful on the derivative and everything we've covered so far.